All right, we are live. So let's go ahead and talk oxidation and reduction. This lecture should be a little bit quicker than the other one. This one is more about concepts. There will be some practice. All right. So, oxidation and reduction is talking about changing oxidation numbers. So, oxidation means losing electrons. Means that your oxidation number, not quite the same thing as charge, increases, becomes more positive, less negative. So, for example, here we have hydrogen. It goes from neutral hydrogen to a hydrogen ion. So it goes from an oxidation number of 0 to an oxidation number of positive 1. Okay. Its oxidation number has increased. It lost electrons. Reduction is the opposite. Reduction means gaining electrons. Your oxidation number decreases, becomes more negative, less positive. So here we have oxygen. Neutral oxygen gains electrons to become oxygen 2 minus. Its oxidation number has gone down. It has been reduced. So where oxidation is named from oxygen, because a thing gains oxygen, has been oxidized, reduction is named for oxidation numbers going down. That's why it's called reduction. So let's take a look here at the reaction of magnesium metal with hydrochloric acid. We'll identify what species are being oxidized, what species are being reduced, and what species are just spectators. So, magnesium plus HCl goes to MgCl2 plus hydrogen gas. So starting over here on the left, magnesium is the neutral metal all by itself. Therefore, it is going to be oxidation number 0. Okay, remember, neutral element, oxidation number 0. Likewise, over here on the right, hydrogen is also a neutral element all by itself, oxidation number 0. So now we come back over here to our hydrogen chloride, our hydrochloric acid. Hydrogen is +1, chloride is -1. Nice and simple. Coming over here to magnesium chloride, chloride I should say, is still -1. And magnesium is going to be +2. So, chloride is just a spectator. It's not doing anything in this particular reaction. Okay. Meanwhile, we have magnesium going from 0 to +2. Its oxidation number is increasing, becoming more positive. Okay. So it is being oxidized. Over here we have hydrogen. Hydrogen is going from +1 down to 0. It is being reduced. And then we have our chloride as a spectator. So this is why we care about oxidation numbers. Okay? They let us keep track of the movement of electrons. Sometimes that is very explicitly, very definitely, very real transfer of electrons, as in this case. Magnesium is starting out as, going back to our Lewis structures, it has those two s electrons in its valence shell, and then it becomes magnesium 2 plus with no electrons in its valence shell. It's losing those electrons. It is specifically losing them to hydrogen. Okay. Hydrogen is going from H plus. It's gaining those two electrons to become hydrogen gas. Okay. So in this case, it is very explicitly an actual exchange of electrons. All of chemistry, chemical reactions, well, not all, most of the interesting chemistry, chemical reactions, involves the movement of electrons. Redox reactions makes that very, very explicit. And in the case of a reaction like this, it is definitely a very real exchange of electrons. Other times, it gets a little bit more fuzzy. But electrons are moving. And as to why we care about that, usually it's because of batteries. You have electrons in one spot, they move to another spot, they get there by moving along a wire, and you get them to do work. Okay, electricity. All right. So that's one example of oxidation and reduction. Magnesium has been oxidized, hydrogen has been reduced. Oxidation and reduction always take place in pairs. They always happen together. They never ever happen independently. Now, more vocab, because why not more vocab? We also talk about agents. An agent is something that does something, something that acts. Okay? So a reducing agent is a thing that causes reduction. An oxidizing agent is a thing that causes oxidation. Because oxidation and reduction never happen independently, a reducing agent is the thing being oxidized, and the oxidizing agent is the thing being reduced. Isn't that fun? Okay, they never happen independently. They always happen together. So, let's take a look at this reaction here. Okay, we have rust, or iron ore, combining with carbon to make iron and carbon dioxide. Which one is the reducing agent? Which one is the oxidizing agent? So once again, we hop back over to paint so I can scroll it out for you. All right, so to identify our oxidizing agents and our reducing agents, we need to identify what is being oxidized and what is being reduced. So, carbon and iron, once again, neutral elements. Oxidation numbers are 0. Oxygen, no peroxides here, so all of our oxygens are -2. Oxygen, in this case, is neither being oxidized nor is it being reduced. Okay, therefore, it is neither an oxidizing agent nor a reducing agent. So, we have 3 oxygens and 2 irons, meaning that in this compound, iron has an oxidation number of +3. And over here, carbon has an oxidation number of +4. So that means that iron is going from +3 down to 0. So it is being reduced. Carbon, on the other hand, is going from 0 up to +4. It is being oxidized. Iron is being reduced, therefore it is the oxidizing agent. Carbon is being oxidized, therefore it is the reducing agent. Okay? These things always come in pairs. Okay? So, iron is reduced, therefore it's the oxidizing agent. Carbon is oxidized, therefore it is the reducing agent. So, here we have tons and tons of practice. I will go ahead and walk through all of these. If you're watching this later, feel free to pause, here, try them out on your own, and then watch me walk through them. For anyone watching live, keep in mind I'm watching the chat, and you can you can ask me questions. So for this first one, we can ignore the nitrogen and oxygen. Okay? The nitrate hasn't changed at all, therefore the nitrogen and the oxygen within the nitrate also haven't changed at all. All we need to focus on is the gold and the hydrogen. So the gold starts at 0, the hydrogen ends at 0. Again, remember our elements, and don't forget your Brinkelhoff. So hydrogen started at +1. Gold ends at +3. Whoa. All right. Now, we can figure out the gold very easily there because nitrate is -1, and there are 3 of them, for a total of -3. The gold has to balance that out, making it +3. All right, so that means gold went from 0 to +3. It went up. That means it was oxidized. Hydrogen went from +1 down to 0. It was reduced. Therefore, hydrogen is our oxidizing agent, and gold is our reducing agent. So we put these together, and that is what we're looking at. Okay. So that is the first one. Now let's look at hydrogen peroxide combining with iron. All right. In this case, hydrogen does not change. Okay? Hydrogen starts out as +1, and it remains +1. Iron starts out as 0, and as we've seen before, in this case, it ends up as +3. Oxygen is changing in this case. It starts as -1 over here, ends up as -2 in water, and -2 in the iron 3 oxide. So hydrogen's not changing, it's just a getting the connection. It'll take just a second. All right. So iron goes from 0 to +3. It has been oxidized and is therefore a reducing agent, while oxygen went from -1 down to -2. It has been reduced and is therefore the oxidizing agent. All right. Don't be confused by the fact that oxygen went from being in one place to being in two places. That doesn't matter excessively much. The important thing here is the change in oxidation number. Excuse me. So let's go ahead and move on to our next problem. That being hydrazine breaking apart into nitrogen and hydrogen. So, over here on the right, fairly straightforward. These are both our neutral elements. Therefore, they're both at 0. Coming back over here to the left, hydrogen is +1. So what about nitrogen? Well, in order to balance that out, each of our nitrogens is going to have to be -2. So nitrogen goes from -2 up to 0. It has been oxidized and is the reducing agent. Whereas hydrogen goes from +1 down to 0. It has been reduced and is the oxidizing agent. Okay. Again, yes, this might look kind of weird. The fact is that we have one compound breaking apart into two things. Yeah, that's not a problem. That's absolutely fine. Things like that happen, not necessarily all the time, but they can happen. Okay, continuing. Last of the examples I have prepared here, we have propane. You all want to talk about propane? Propane accessories? All right, C3H8 plus 5 oxygen makes 3 CO2 and 4 H2O. All right. So once again, in order to identify oxidizing or reducing agents, we have to identify what's been oxidized, what's been reduced. That means finding our oxidation numbers. So oxygen starts out 0. Okay. Pure element, Brinklhoff. All right. And oxygen ends up -2 in both carbon dioxide and water on the right. Hydrogen, meanwhile, starts as +1 over here in propane and ends up as +1 in water. I'm going through these very quickly. It will probably be a little bit more difficult for you until you practice a lot with with finding oxidation numbers. Okay, that's lecture 50, the one I recorded about 2 o'clock. All right, so what is carbon? Well, here in carbon dioxide, carbon is positive 4. It is a little bit stranger here in propane. 3 carbons plus 8 hydrogens equals 0. So 3 carbons plus 8 equals 0, which means 3 carbons equals -8, or carbon equals -8 thirds. Sort of. In fact, propane looks like this. So what you have in reality is -3, -3, -2. So don't worry too much about that. What really matters is that -8 thirds. Carbons are going from -3 and -2 up to +4, meaning it has been oxidized, whereas oxygen is going from 0 to -2. Oxygen has been reduced. Because oxygen has been reduced, that makes it the oxidizing agent. And as the name oxidation will tell you, that's the usual role for oxygen to play. It's not always. Oxygen can be oxidized. It's just difficult. Okay. Carbon being oxidized is therefore the reducing agent. Now, real quick, I want to show you an oddity. I don't think that they would throw something like this at you on the test, but they could. So let's hop to it. All right. I don't know if this particular reaction could take place. I suppose it could. The important thing is just the changes that we're looking at. Now, oxygen, whether we're looking at it in bromate or bromite or perbromate, oxygen is going to have an oxidation number of -2 all the way across. Okay. Oxygen isn't doing anything here. What is changing, though, is the bromine. Okay. It's going from +5 here in bromate to +3 in bromite and +7 in perbromate. Oops, that's a +5, not a -5, sorry. Which means that bromine is both oxidized and reduced. So when it goes from +5 to +3, it's being reduced. When it goes from +5 to +7, it's being oxidized. So what's happening is these two bromate ions are colliding, and one of them is stealing an oxygen atom from the other, stealing the bond, stealing the electrons. So one of them loses those electrons, becomes oxidized. The other one gains those electrons and is reduced. So just follow the numbers is really all the advice I can give you there. Okay. So remember, reduced is the oxidizing agent, and oxidized is the reducing agent. All right. And with that, that is everything there is to talk about with respect to oxidizing and reducing agents. Oxidation and reduction, right? Yes. Next lecture would be how to balance redox reactions. And that will take quite a bit longer. Actually, next will be the activity series, which will not take quite a bit longer. It'll take a while, but not quite a bit longer. And then, after the activity series, will come balancing redox reactions. That will not be fun. But in any event, we are done with this particular set of slides, with this particular lecture. Have a pleasant evening.